on this question, an odd truth, since it is just the pyridine and nothing added to it, there is a nice rule that tells us how it's going to go on. So pyridine, which is a 6-membered ring aromatic with a nitrogen on it, if you see electrophilic aromatic substitution, which is what we have with nitric acid and H2SO4, it most definitely goes on in the, think of it as this ring is kind of deactivated with that nitrogen. And you have deactivators on benzene like the meta position. Well, we don't call it meta if it's a heteroatom, but it is in the exact same location. So 1, 2, 3 nitro. Now, that can be viewed as an absolute, as in if you see pyridine and you see electrophilic aromatic substitution, it is definitely going to third position. But sometimes it's beneficial to have that mechanism show why. So what we're going to do is, and I'll move this over actually, so when that nitro group goes on in that 2 position, it at first goes on, there's still a hydrogen there, and that location becomes a positive. Essentially where that double bond is, we add to 1, the other side becomes a positive. Now, this one's going to stabilize itself because I can move this electron pair there and then move it over here. Actually, I'm going to do that with red ink so I can show you what's going on. That lone pair will form that double bond. This lone pair is going to pop back onto the nitrogen. Need to make this bigger. Can't get back to my blue color. But now this is the double bond and the positives here. It's still in the ring. We still have a lone pair on it. But I also have one more resonance structure where I'm going to move this pair down here. All right, now those 3 things happen, and those 3 resonance contributors happen if I put that nitro in that 3rd position. To guarantee this is a stable one, you need to look at what happens if I put it somewhere else. So what I'm going to do is the same type of idea where I start with the pyridine there, leaving the double bonds off, because now I'm going to put the NO at the 2 position with the H, which means that becomes my positive. Same type of thing, I'm just going to move it around, but this time I'm going to get one particular problem. First move, I'm just swapping these 2 essentially, so this becomes the double and there's my positive. But we're going to do one more where these 2 switch, and it's not going to like that because it ends up putting the positive on the nitrogen. And what's weird about that, I don't necessarily normally care about a positive on a nitrogen, but this nitrogen only has 3 things on it and that positive. Nitrogens that are happy to be positive are ones that have 4 bonds. So this one's not stable at all, which why I put a U underneath it. And technically, if you actually put that nitro group in the 1, 2, 3, 4 position, you would end up with the exact same problem where you're going to end up with a positive on the nitrogen, which is why adding the electrophile to the 2 or the 4 position is unstable. So, single substituent, 3-nitropyridine. To be quite honest, if you're comfortable with these, this is one that you wouldn't necessarily need to actually draw out. It becomes a problem if I have you start with 3-nitropyridine and then nitrate it. Because if there's something already on there, you kind of need to draw these again and see how that other group affects you. Especially if it's a nitro group, because nitros are deactivators.